Are we good to start, or should we give it a couple?
Yeah, I'll just say some announcements real quick.
Okay.
We'll give it like another 30 seconds. I think so.
I'll like scroll for you too. Like once you get to your voting part, I'll.
Yeah.
Okay, guys, we have some very awesome guest lecturers today that are going to guest lecture on SwiftUI Part 1. Real quick before that, just a couple announcements. So remember that A3 was due yesterday, and A4 midpoint is due next week. Again, this is just like a completion thing, so just get submitted. And A4 is due, like the final is due in 2 weeks on Tuesday, so like a little under 2 weeks actually. And yeah, if you remember, if you like want to fill out the preference form for the hack challenge, that is on the hack challenge ed, and it is due in like a little less than a week now. I believe it's next Tuesday. Yeah, if you're not in the ed hack challenge ed, then just come up to me after class. I'll get you added to it, so you can fill out those forms. And yeah, please give your attention to Angelina and Kayla.
Yeah. Hi guys. I'm Angie.
I'm Caitlin.
Yeah. I'm a sophomore, and this is my first semester on app dev. I work on transit. We didn't plan this, but yeah.
Oh, it's fine. And I'm a junior studying CS, and this is my third semester on app dev, and right now I'm working on Uplift.
Yeah. So quick recap on last lecture, you guys learned about persistence, which is basically like if a user exits out of an app, the data still saves, which is kind of the idea that the data will persist. And then SnapKit as well, which makes setting constraints with auto layout a lot easier and a lot more simple as well. So the stuff that we'll be talking about today won't really build off of that, but does anyone have any questions before we move on? Okay, if not, we'll get right into it. So, what is SwiftUI? You guys have probably heard of this framework already, but in a nutshell, it's a declarative framework developed by Apple to build user interfaces. And it was introduced back in 2019, kind of as a means to replace UIKit, which is the framework that you guys have been working on throughout this past semester so far. And the point is, it's that it allows for more like concise and readable code, which means that it's easier to maintain and extend. So a lot of newer developed apps have been transitioning to SwiftUI, which is why we call SwiftUI the future of app development. So for some of our older apps like Eatery, that was developed in UIKit, but for some of our newer apps like Caitlin's working on Uplift, those are developed in SwiftUI.
Yeah, and I guess I can talk more about what the difference between imperative and declarative is. So let's start with this one. So we're going to start with the imperative approach, and I'm going to use an analogy to kind of like talk through it. So let's say we're trying to get a box of Cheerios at the store. So for imperative, we're going to go through all the steps on how to do that. We go to the store, we go to the aisle of Cheerios or like for a cereal in general, and then we find that box of Cheerios that we want, we check the price, we go to the cashier and we check it out and we go home. And this is defining how tasks are being accomplished. So how do you want to get this box of Cheerios? And to kind of just connect it back to UIKit, we're having the view controller, right? And we're setting up this table view, so we need to define the data source, the delegate, to register this all the cells in it, and to set up the constraints as well. So we're showing like how to make this table view cell. And the table view cell is actually this one, sorry. And then there's more code. There's just a lot of code, right? This is too much code. So now we're going to talk about declarative. So this defines what tasks should be accomplished. So to talk about the analogy again, it's actually just go to the store and get your box of Cheerios, and that's it. And to kind of compare, so I don't know if all of you have seen SwiftUI code before. So basically, we just have our content view, and we just say we want a navigation view, we want a list, and we want to have this navigation link, so this takes you to the user detail view, and it looks like a text. And that's all it is. And this is basically representing a table view. Is there more code? Nope, that is it. So that's the beauty of SwiftUI. We're told what to show based on the current state, and the SwiftUI moves between the user interface layouts for us, and we just have to define the rules that our views should follow, and SwiftUI enforces those rules. Okay.
Yeah, so I'll show you guys how to create a SwiftUI project. You guys don't have to follow along with this. This is literally just how you would create it, but if you go to Xcode, and then you go to File, New, and then Project, make sure that it's set on iOS here, and then you'll just click on App. And so for our project name, we'll just call it Sample for now. But in this interface selection, make sure that it's selected on SwiftUI instead of Storyboard. If you were to use UIKit, you would use Storyboard instead. And for the testing system, make sure that it's also set to none as well. I think it was set to something different for mine, but we're not going to be doing any testing for our sample app. And then you can just hit next and create in the folder that you want your project to be in. And so while we're waiting for that to load, we can kind of talk about the file structure that comes with when you first create the app. So there's really two main files. So the first one is sample app.swift, and that just contains the code that's executed at launch and is kept throughout the app's lifetime. So in UIKit, you had, I think it was like app delegate and scene delegate, but it essentially just tells Swift where an app's entry point is. So in this case, for SwiftUI, it's literally just the name of your app plus the word app.swift. And then the second file that we see is contentview.swift, which contains the code that defines the UI for most of our app, and is most likely where most of your code is going to go. So if you do click into sample app.swift, all you'll see is that it calls content view within it. So this is what the general structure of content view would look like. So you have a struct called content view that conforms to a protocol of view, and then within that you have you declare a property called body that returns a type of some view. And that sounds like a mouthful, but if you kind of understand how it's supposed to work, it's actually really straightforward and really easy. So the first part of this is just import SwiftUI. It's pretty straightforward, and it's usually the same in most languages. It basically just imports the framework that you're going to be using. So because we're using SwiftUI, you're going to be importing SwiftUI. But if you were to use UIKit, you would import UIKit. And then the second part is actually the struct, where you're creating a struct and then conforming it to the view protocol. And that's because anything that we build is like always going to be within a view. And so the actual return type is pretty complicated, and we'll discuss this later on. And so within this, I think when you first create a project, it'll create like an image of a world as well. But for this, you're really only just creating a text that says hello world. And then the last part is probably the coolest parts of SwiftUI in my opinion, but this is live previewing, which essentially just means that if you were to change something in your content view file, you would actually see like a live preview of how that changes in the actual app. So we can do this really quick. So like right now it says hello world, but if I wanted to say like hey world, you'll see that it automatically updates in the app on the right. Or you can't really see it, it's kind of small. That's the wrong file. Okay, that's also the wrong file. Okay, yeah, but it'll automatically update it in the preview on the right. Oh, okay, well, I guess what do we notice about this? I kind of gave it away, but the content view is a struct, and Caitlin will talk a little bit more on that.
Yeah. Okay, so what does SwiftUI use structs, or why does SwiftUI use structs for views? So first of all, it's performance. Structs are faster than classes. And this is because they live in different places in memory. Structs are stored on the stack, and classes are stored on the heap. So this really matters for creating apps. And then it's also a lot simpler. So in UIKit, every view is a subclass of UI view, which contains hundreds of properties and methods that we may not even use. So making a subclass of a view inherits all the properties of that view, and it's not really necessary because you don't need all those properties. And classes are just too intelligent. We have a lot of functionality that we don't need, so that's kind of similar to what we were saying before. So because of this, things will just get messy. So now we need views to be dumb and simple. Their only job should just to be converting data to UI. With structs, there are no inherited values, and everything you see is all of it and nothing more. Okay, let's say we want the text "Hello World" on the screen. We just have this text and we put "Hello World." And if we want the image with an app dev logo, we just say that. And then we continue with a rectangle, we just say rectangle. If we want the color red, color.red. And here's a bunch of other different kinds of views that SwiftUI provides. So basically, I think the one that we're using this lecture is called a list, and that kind of acts as a table view. So we can talk about that later. And there's many more views than this. Okay, so let's say we want a red text "Hello World" with a font size of 24, a black background, and a padding of 20. And let's say if we were doing it the imperative approach, it would be like this, but that's not what SwiftUI does. This is actually wrong. The views are not like this, and they're not that smart. So how do we create this modified view without putting all those properties inside of this constructor that we created? And then we're going to move on to modifiers, and Angie will explain that.
Yeah, so modifiers are methods that you can actually attach to your SwiftUI views. And there's a ton of modifiers out there. Caitlin showed you a couple. And then you can actually customize your own modifiers as well, which is pretty neat. So you can see that here's a couple examples. So like if we wanted the "Hello World" to be red, we would just add the foreground modifier to "Hello World" with .red, and that would change it to red. Font, background, padding. There's a lot of different stuff that you can kind of play around with and combine to add to your views. And these modifiers are actually like really straightforward in how you understand them. So like if we took a look at the image of the app dev logo, if we saw like .border, .blue, it's pretty obvious that it means that just makes the border color blue. So then isn't this the same as changing the view's properties? So if you remember what Caitlin said, structs are actually immutable, which means that if you change a property of that, of a struct, the entire struct gets deleted, and then when we add a modifier onto it, it creates like an exact replica of what it looks like before with that added modifier. So all of this happens really fast, and it kind of just goes on in the background, but that's kind of the concept of what happens when you do happen to add a modifier onto it. So we can kind of see this. You guys also don't have to follow along with this demo. This is just kind of showing you how it works, but do follow along when Caitlin demos her thing. So like, say that we wanted the text, we can keep it "Hello World," but if we wanted to make the color red, we can just add color.red. And if we wanted to change the font size, we can do font.system size, and we can make it like 24, or maybe a little bigger, 30. So all of these are modifiers that I'm attaching onto the text "Hello World." So if we wanted to change our background to the color green as well, you can do .background color.green. And then finally, say I wanted to add a padding of like 20 around this text. And you can give it a moment, but you'll see that it doesn't actually add that padding on, or you can't visibly see that padding. What's kind of happening is that the padding is actually there, but because you're kind of like, you're adding these modifiers in sequential order, what's happening is that you're first setting the background of a text to green, but then you're adding the padding around it. So if we actually wanted to see the padding of 20, that's green around the text, you can just add it in front of the background. So it sets the padding to 20, that kind of goes around the text, and then you change the background to green. And if we wanted to make it a little bit pretty, we can add like a corner radius to it too. So that's kind of how modifiers work. It's really simple, really straightforward, and you don't really have a lot of the extra code that you see in UIKit as well. So,
Question in the back.
yeah.
So how do you distinguish between the container and actual words that's inside of it and where the styling goes?
Yeah, so the styling that we use, if I'm understanding your question correctly, if you wanted to add like some sort of styling or some sort of modifier on, you can just use the dot, and then it'll give you a bunch of stuff that you can use to style whatever you want to do with the text.
So like how do you distinguish like the entire container, like the entire green box with the words in it and just the words? Like whenever you're adding those styles.
Are you talking about like the padding and that's the
Yeah,
other
so,
container?
Like, well, like if you would add padding to like the green box as opposed to just the words containing them.
Oh, this is all being applied to the text actually. So the padding is creating the space away from the text, and that's what you see that's green. And if we apply the padding before we apply the background, or the background first, and then we apply the padding. Wait, actually.
So it's more so about the order.
Yeah, it's more so about the order, and it'll change how the styling will look. Yeah.
Yeah, and kind of how that works, it's in sequential order because every time you add a modifier onto it, it like creates a new instance of that text with the other modifiers that it has on, and then it adds a new modifier onto it, which is kind of like why it works in that way. But yeah, good question though. Ooh. Okay. Yeah, so modifier order matters. This is just a reiteration of what I was talking about earlier, but just make sure that whenever you're adding the modifiers, you add it in the order that you actually mean it to. So you can kind of work it through logically as well. But yeah. So if we're actually creating a different view, then what's the actual return type? So if we see these two texts right here, even though they're the same text, what we'll see in a demo that I'll show in a bit is that these return types are actually different. So, okay. And that's why that's why we have some view, which means that even though these return types are different, they'll all conform to a view. I think that'll make a little bit more sense in this demo. So there's some code that I've written earlier that essentially what it'll do is create a button, and then it'll print out the return type of that button. So right now the button just has some padding around it and then a frame that kind of declares the size of the button that we see. So if we let that run, if we give it a moment, what you should see is that there'll be a button up at the top and then another button at the bottom where if you click on it, it'll print out the return type. I think it just might take a moment. Okay, there we go. So we have a hello world button that has, what was it? Padding. And then if we click on the return type, you'll see it's printed out that there's like this modified content with the button and a text with padding and a frame layout as well. But if we wanted to make it so that the color, or that the button was a different color, and we run it again, hopefully it'll be a bit quicker this time. Okay, yeah, so if we click the same button, you'll see that the return type's actually different because we're adding a different modifier onto it. So in this one, you'll see that there's actually a foreground style modifier color as well. That's different than the previous Hello World button that we saw earlier that was just blue, because we added the foreground modifier, or foreground style modifier onto it. Tongue twister. Okay. Yeah.
I think that's the goal.
Yes.
When you print type of button,
Mm-hmm.
considering that you have like two buttons
Yeah, that's a good question. So right here up at the top, I define this button where I just say like let button equal this button.
Yeah.
So when I'm saying or when I'm telling it to print the type of that button, I'm just referencing the button that I created up there. So it's just the top button.
So what if you name the bottom button? Or have you just not
Oh,
named
the
it?
bottom button's really just there for me to click on. Like there's really no
There's
point.
no reference to it.
No. Yeah. But yeah, this button right here is always referencing the top one,
Yeah.
which is why we see a change because we changed the color of that top one. But yeah, good question. All right, so now that you imagine that you have like a bunch of views, so with the ones that we were working with right now, we had like maybe 2 or 3 modifiers attached onto them. But say that you're working with a lot of different stuff, like you can have text within buttons, within a bunch of different things, and what you'll realize is that the return types will gradually get more or longer and longer and more complex. And so because we don't exactly know what the return type is, this is why we use some view, because we know that it's always going to be some view that conforms to view. Does that make sense? That's a little bit confusing. Okay. And the last thing that I'll go over before Caitlin does the demo is the concept of layouts. This is something that we use all the time in SwiftUI, and it's like, so the first one is HStack, which stands for horizontal stack, and it's pretty straightforward. It's a view that arranges its view in a horizontal line. So if we created a HStack with the text like Cornell and AppDev, it'll basically just put the 2 texts side by side in a horizontal line. And that's the same thing that happens with a vertical stack as well. We call it VStack. So if we printed those same 2 pieces of text, Cornell and AppDev, in a VStack, they'll be printed up and down instead of side by side. And the last main layout that we use is a Z-stack, and that's a view that overlays its subviews, but it both aligns them on the same axis. So for instance, in this one, we have a red background, but then we add the text AppDev onto it. These are really the 3 main ones that if you were to code in SwiftUI, you would probably encounter most often in, but if you, and a spacer, which basically just spaces the 2 texts that we see apart. Yeah, that one's also pretty straightforward too. But there's a lot of other layouts that are lesser used, but they're definitely useful as well. There's like a list of them here. There's more that you can use. But Caitlin will show how to use more of these in the demo that you're going to be using, or that you're going to be making.
Yeah, so does everyone have access to the GitHub, and have they cloned it already?
Do you want to walk through that?
Yeah, sure. So do you have the
Yeah, of course. I think it's this. Or wait. Right, yeah.
Yeah, so you can just follow the steps on the course textbook. So you can git clone, and then you take the URL. And then we're going to just start on the main branch, but we're going to have multiple different branches. So if you get behind, you can check out the next branch for the next like area of content we're going to cover. Okay. Yeah, that's kind of small. Where are the slides?
Oh.
It's right here.
Yeah.
Okay, so this is basically the basic app that we're gonna create. So we're gonna create a list of birds, and then it's a birdwatch app. So basically, this number indicates how many birds you've seen of this kind. And then here's some of our like members or past members. Oh, there's a
Does
video
that
as well.
work?
Yeah, and then it's a scrollable view as well. So that's what we'll be creating. So let's go back to the code. And we're just gonna restart all of this and start with just the basic body. So we're gonna be in our content view, and first, if we're looking back at the slides, we're gonna start off by making one row of this bird. So let's use Antoinette as an example. So right here we can see that there's the number 6, and we need Antoinette's name here and then her location as well. So we're gonna start off with that, and to do that we're gonna use the text view. So let's just make 3 text views to start off. So we have the number 6, and then we can see the preview update as we code.
Wait, I think you're on mine. Or like
Oh, it's like
the other one that I created. But don't you need the photos?
oh, is this the okay? I'm just gonna move this one. Alright, they look the same, sorry. Okay, so we're gonna start off and let's try to reload this. Okay, so let's make the text with 6, and then we also have Antoinette's name, and then we also have her location, which is New York. Okay, and we see that it's all been updated on the preview, but right now it's just all vertical right now. It's 6 Antoinette New York, but we want it to look like this. So we want the number to be on the left side, and then we want the name and location to be on top of each other. So for the name and the location to be on top of each other, we want to use some sort of layout. And this will be the V-stack because they're vertically aligned. So let's use the V-stack, and we can wrap it around the 2 texts, and this will show that these 2 texts are inside this V-stack together. And right now you don't see any change because they're already vertically on top of each other. So the next step we need to do is make the 2 and then the V-stack right here horizontally aligned, right? And what we do with that is use the H-stack, which is horizontal alignment. So we can wrap all of this with an H-stack. And this will say that this view and this whole view are going to be inside of this H-stack together. So that's why they're next to each other like this now. So styling wise, the numbers and the name and the location do not look like what we have here. So what we want to do is basically set the font and set the weight of this because this is also bolded. So we can use modifiers to do this. So under the 6, we can set the font to some default font. So we can use dot to indicate that. And it should give me a list of different default fonts that we can use. And we're just going to use large title because it's in the bigger size. And we can see that grow right there. And then we also want to make this bold. So we can actually use font weight to set it to dot bold. Yeah, and that's one of the options. So there you go. It looks like the design that we have over here. And we can do a similar thing with the other fonts as well. Or the other text, sorry. So Antoinette, it looks like it's bolded as well. So we can add a font weight to that one as well. So font weight bold. And then the last one looks like it's italicized. So we're going to do that as well. So we can use the modifier called italics. And there's like many different modifiers, so you definitely don't have to memorize this. And you can always Google more modifiers if you ever want to make an app in the future. And then I think we also, because it's a little bit more, have more weight to it, we can also just set this font weight to, I guess it already had autofill something for me, but we can use medium for this one. Okay, so we also have this bird image that we want to import. So if we look at our assets, similar to UIKit, we can just take the name of the asset and then we can use it in our code. So we have Antoinette's bird asset right here. So for this one, we can use the view called image. And where we want to put that, we want to put that in our H stack, right? Because it's on one of the ones that are horizontally aligned with each other. So we're going to put that at the end of our H stack inside. So we're going to use the view image, and the name of this bird is Antoinette. And that's the asset that we found here. And it's way too big right now. So we want to use some kind of modifier to scale it down. So to set a certain size to this image, we have to use this modifier called frame. And what this does is set the width and height of this image. So let's set it to, for example, width equals 100, and then let's say the height is equal to 100 as well. But it looks like nothing changed except that the text that we had before went underneath the image. And why is that? So for some reason in SwiftUI, you have to explicitly say that we want this image to be resized instead of just having this view be this width and height. Because the reason why the text underneath shifted is because they know that the view is 100 and 100 width and height, but it doesn't know that this like asset has to be changed size as well. So we're going to use this modifier called resizable, and it will do that for us. There you go. And let's look back to our design. So it looks like we have some space in between the image, the text, and the other text. So for that one, we can use that view called spacer that we were talking about. So we can put that inside of our HSec in between these different views. So we can put a spacer here, and we could also put a spacer here. But if we look back to our design here, it doesn't seem like our spaces are equal on both sides, and it looks like the one on the left side is a bit smaller. So instead of putting a spacer there, we can actually use a modifier called padding, and this will add some kind of padding on the text, but we don't want padding around the whole text, right? We just want padding on the right side. So similar to UIKit, we can use the trailing aspect of this padding. So down here we can add the modifier padding, and we can specify that we only want to do it on the trailing edge, and then we can put, for example, 30 as the padding. And there you go, you have it. And the reason why we're not gonna put all this like spacing around it is because we're gonna use our list later, and it will like, we're just gonna put this whole row into it, so we don't need to actually have that padding right now. So, okay, so we finished the first section of it. So if you wanna catch up, you can use git checkout 1-layouts. I think it's also on the lecture textbook, so you can copy paste that as well. So I'll just do that right now as well to just show you guys. So we can't actually check it out without like committing or stashing your changes. I'm just gonna like stash it because I don't really need it. So we can git stash, and then it'll just like remove all of our like progress, and then we can git checkout 1-layouts, and this will take the version from our GitHub. Okay, there you go. And then we have all the updated code right there. Okay, so the next thing we want to do is refactor this into another view. So basically, we don't want to have all this code in the content view, because what if we want like tons more code? Then it's like super unreadable. We don't know what this HStack is doing. We don't know what everything is doing. So we want to have some sort of name to put all of this code under so that it's easy to understand. So what we can do, just like the var body, we can specify some kind of name for this. For example, we could use bird info row because it's one of the rows on this list. So down here, I'm going to set it as private because we don't need access to this outside of this file. And then it's going to also be a variable, and we'll call it bird info row. And it's also going to conform to some kind of view. So it's exactly the same thing as our body right here. And what we're going to do is just take all our code and put it there, because we want to say that all this code means that it's a bird info row. And then we can actually just delete all this. We don't need this anymore. And we can call it by writing bird info row right here. So this will actually put that view inside of body. And it's just like a lot easier to understand if we just have that up there. Okay. So if we look at the bird file right here, I'm going to kind of walk through what this is. So we have this model called bird. It's kind of similar to what we have been doing before. So this has properties of name, location, image, count, and this is our array of birds that we're given. So these are all the birds that we actually see on the design right here. And we're going to use this array to create this list of birds. So how do we create that list? Well, there's actually this, we have this view called list that we can use. So it's very self-explanatory. So let's start with making that list. And what the list needs is some sort of data to pass in, and that's our array of birds that we had before. So our array of birds is called birds, so we can just pass that in. And then for list, we need some sort of ID to identify all the information in here. So it's similar to the UI table view. So in the UI table view, we need to like dequeue the cells, right? If we scroll it over, we need to make sure that we dequeue those cells so that not everything is in memory, because if we have so much data, then it's going to take up so much space in memory, and we don't want to do that. And then that's why we have that reuse identifier as well, to identify that place, that cell that we're that's going off the page, and then we're using that same space to have this new cell that we're scrolling down. So here that we're doing that same thing, and we're gonna use the actual object itself to identify it. So we could just use like the name of it, we could use the location, we could use the image, but it's very possible that these names could be very similar. Like if there's two names that are Alden, then it would be like, how would you identify the difference between those two objects? So we're gonna use the object itself, and the way we do that is use \self. It's very weird notation, but this basically references the actual object itself that's being passed in. And the rest of the structure of this list is kind of similar to a for loop. So we're gonna pass in the specific bird that we want, and we can use that specific bird model in that array. So for example, this one, and we can create this bird info row that we were trying to create before. So the only issue with this right now is that we have preset like count, preset name, location, but we want to make it specific to the different birds that were being shown here. So instead of making this a variable, we're actually going to change this into a function. That way we can pass in different properties of the birds that we want. So instead of it being a var, we're going to change this into a function, and then similar to other languages, we're going to use parentheses to put in the parameters in there. And then instead of this colon, we'll use this arrow, and that will be the return type of it. And basically, we're still returning a view, some kind of view, so that's going to be the return type of this function. So what kind of parameters do we need? So that's all the properties that are inside this bird model, and that's what we want to be displayed here. So we're going to actually use that as well. So first we need the name. First we need the name, and that's a string. And then we need the location, which is also a string. We need the image, which is a string because we're using the string from the assets. And then we also need the count, which is actually an int, if we look at our model. Yes. Okay, so now we can go back to our list, and we can call this bird info row similar to other functions that we have. And we can pass in those different properties from this specific bird. So how do we do that? Well, we have to remember that this bird is an object. So we can call it by using bird dot, and then all these different properties are actually listed here. So for the name, we want bird.name. For the location, we want bird.location. For the image, we want bird.image. And for the count, we want the bird.count. Okay. And the reason why we're still having some kind of error here, it says that initializer requires that bird, it conforms to hashable. So it's talking about our model over here, and that it's missing this hashable keyword. And the reason why we need hashable is because this allows the struct to be uniquely identifiable by its contents, so by the actual object itself. So basically, we're using the object itself as an identifier, so that's why we did the \self before. So that's why we need this hashable protocol to conform to, because it does that for us. So we'll see here that the error goes away, and let's see if anything pops up after this loads. Okay, it's taking a while. Okay, and the reason why we only see one bird is because we did not change our text or anything inside here. So we're gonna actually use the arguments that we passed in so that we specify what type and what properties we want in this view. So for this one, that was the bird.count. So we're gonna use the count from the function because we're gonna pass in those arguments and we're gonna grab that information here. And it's giving me issues because count is actually of type int and text only takes in a string. So we can actually just cast that to a string. Oh yes.
Is there any reason why you don't pass in the bird object when you pass in like its properties?
The bird object when we pass in the properties?
The bird info row function.
Oh yeah, we could definitely just like pass in the model if we wanted to. That's also another option. Yeah, that would totally work. Yeah. Okay. And then we want to change this to the name. And this will be the location, which is also a string. And then the image is also a string, so we can just pass in the image. Okay, so now we see all our birds have their unique numbers, their locations, their names, and images. Okay. So does anyone have any questions so far? Okay. So if anyone needs to catch up, we can do the checkout to the next one, which is to-list. So I'm just gonna stash my changes and then we can do git checkout to-list. And I'll update everything here. I do think I might have missed something earlier. So here, this VStack has this property called alignment. So basically, these two texts, these locations and names were actually centered earlier in this view. So to shift everything to the left side, we can use this thing called alignment and we can set it to dot leading. So that will just push everything to the left side of this view. Okay. And we also have this font that everything shares in this text. And the reason why we can, we don't need to put this font inside of this text and this text individually because they have the same type of font. So we can actually just like put this modifier outside this whole VStack and it'll apply this modifier on every single view inside this VStack. So it just makes code more cleaner and just like less code in general. Okay. So the last thing I want to do is kind of refactor this to if we had like a ton of different pages or a ton of different like information we want to show, we don't want to put this all in this one file. So we can actually create this new file that we want to like represent this one page and we can call, in here we can actually add a new file from templates. And this will take you to this screen and we're gonna use a SwiftUI view. And we can just call this bird list view because it's a list. Okay, so now we have this bird list view. And we're just gonna take all this code we made here and move it there. And it's very much similar structure here. So we have the body here. So we're gonna just take everything that we have in this file inside of this content view. And we're gonna put it here. Okay, so if this loads, this page, it's pinned on bird list view. So this is what's showing on this screen. But if we delete everything we made here, so if we delete this function that we created, and if we delete everything that's in this body, then nothing is going to show up. So how we make this all connect back to this main view, this content view, we can just call this struct that we have here because this is a view and we can put views inside views. So right here we can use bird list view and we can call that right here. And if this reloads, we'll see the whole bird list view here. So this just makes code a lot cleaner as your files grow and how many different pieces of code, different kinds of information, different amounts of pages that you have, and this will just make it a lot easier to find what you're looking for. And typically we use a different file to kind of just say that this is a separate screen. So yeah, is there any questions? Okay, I think that's all for this demo.
Yeah, so you guys have probably already seen the similarities with UIKit, but this is basically just a collection view. Caitlin started off by making the individual cells and then kind of created it into a list, except it's a lot more straightforward, and I think, to me at least, it makes a lot more sense just logically that way. For the hack challenge, you do have an option of using UIKit or SwiftUI. I know this course has mainly been taught in UIKit, but people, like I know Peter used SwiftUI for his hack project as well, or hack challenge project as well. But you guys do have the option of. And then on next Monday, you guys will learn a little bit more about SwiftUI from Charles and Adeline. But to wrap up this lecture, we're gonna do a quick Kahoot. Oh. Sorry, that's actually so, can we cut that part out? That's actually so embarrassing. Wait, okay. Also, join the hack challenge ed discussion. Oh, why are you guys animals?
Oh, that's the new Kahoot.
Oh, really?
Yeah, fancy movie. So we use the act up Kahoot, but it's like I don't know upside down.
Is there a way to turn the sound up?
Is it mute?
Oh. Okay. Alright. Let's hope all of these are right. We kind of covered this briefly at the beginning of the lecture, but kind of think about what the two words mean. Yeah, okay, nice job. Declarative is kind of like, or it's kind of basically how it sounds, like you're kind of telling someone to do something. You're declaring. Awesome. True or false? A blue button and a blue button with a black background have the same return type. Okay, yeah, this was kind of a trickier question. I think this is also kind of just a harder concept to like wrap your minds around, but remember when I changed the color of that button, the return type output that it printed was different. Which of these is not a layout? Awesome. Yeah. I just chose a random letter to add to it, but yeah, WStack is not a thing. I don't think so, right? Okay. There's some stuff that I don't know too. And then last question. Arguably the most important question. Don't worry, guys. Yeah. No, but Charles and Adeline are great people. You're gonna learn a lot from them. So
These should be wrong. These should not be optional.
oh, sorry, I was feeling nice.
Go up Monday.
But yeah, all right. Let's see. Aww. The second place is getting like George Washington here. But yeah, thanks for coming, guys. Make sure to be thinking about your hack challenge because that's coming up really soon.
Quick reminder, guys. for A4 is due next Tuesday, and then
So how do I
the
stop this
final is
recording?
due the Tuesday after. Also, if you make sure you get your 8 reads in, I know there's
Oh, I don't
still
like
a bunch
that.
of outstanding